For the next talk, in this room we have Joseph Bradley talking about deploying MLlib for scoring in structured streaming.
I'm Joseph, and I'd like to talk about a deployment setting for machine learning, which is a little bit different than what Nick was just talking about. Hopefully you did hear his talk, because he gave a lot of great background on a lot of the challenges in moving machine learning to production, and talked a lot about a setting, which I won't be covering here. About me. I work at Databricks, mainly on Apache Spark and related projects. And just quickly about Databricks. We were founded by the team which started the Spark project, now Apache Spark at UC Berkeley. And we're trying to make big data simple through our unified analytics platform. I won't really talk more about Databricks today, but I do want to dive into our main topic, which is deploying in streaming. And to motivate this, I want to talk about a toy application, or example application, which is like an ideal setting for using ML and streaming. So here I'm going to be talking about monitoring web sessions for bots. The idea being that bots and humans may come to your website. You don't want to waste time catering to the bots. And so eventually you want to identify them and kick them out. But you're not in a huge hurry. It's okay if they're there for seconds or even minutes maybe. But eventually you want to kick them off. So say you have incoming web activity logs. Of course, this is a constant streaming source and sort of the ideal type of data, large amounts of incoming streaming logs to process with Spark Streaming. And what we're going to do is want to feed those through some featurization logic to compute features, feed those features into some machine learning logic to make a prediction about bot or not. And then let's say we're going to dump these to some cache of predictions. And that way our web applications can periodically do API checks against that cache and kill a user's login session if we believe that we're quite confident that that's a bot. Cool. So this application is kind of divided into two parts, the streaming job on the left and the web app on the right. I won't be talking about the web app, of course, but the focus is on streaming, where we have this constant stream of incoming data. We want to make decisions reasonably quickly, but it's okay if it's not, millisecond or even second. Multi-second or minute may well be fine for removing bots from the web app. Cool. So Nick already covered a lot of challenges for productionizing machine learning, and if you missed his talk, I would check it out. I'll cover a few at a high level. Of course, models are traditionally produced by data science or machine learning teams, and after training those models, the models have to be shipped somewhere. We'll just call it a prediction server, so that you can feed results to the user, which may be an actual human user or, say, a web application. Now, this comes with a lot of challenges, of course. Some common topics are how do you serialize the model to export it elsewhere? How do you deserialize it in order to make predictions in your servers? And how does that prediction logic match up, especially when you start having separations here? Data science and engineering may often be separate teams and even deployment environments. And how do you maintain this logic across those? Featurization logic, of course, can be a really thorny issue. You're not always deploying a vanilla linear model. You're deploying a long series of featurization steps, maybe multiple models, ensembling, et cetera. And maintaining that logic across both teams, deployment environments, versions, and so forth can be really challenging. So just to sum up the challenges in productionizing ML, which I'll mention, they include sharing models across teams, across different systems and environments, maintaining identical behavior, both now and in the future. So this is sort of presenting some of the challenges, and what I want to talk about is a toolkit already existing in Apache Spark with ML pipelines and structured streaming, which sort of out of the box addresses a lot of these issues. That said, if you did try to do this before Spark 2.3, you may well have run into issues in your ML pipeline in terms of not being compatible with structured streaming. So what I want to spend this talk doing is really talking about issues you may have hit before, improvements done in 2.3, and some of the lessons to keep in mind from that, especially if you're writing your own custom logic for deployment. So in our toolkit, the first thing is ML pipelines in Apache Spark. So I won't go into a lot of detail here. If you look up ML pipelines, there's a great guide right in the Apache Spark docs and many talks out there as well. But essentially, they encapsulate a lot of the logic of featurization and prediction. So you might have an original data set, say in this case, some text reviews where you want to predict a label which is a rating. Maybe call this sentiment analysis. Your ML pipeline might do some feature extraction, taking that text, breaking it up into words, hashing those words maybe to a feature vector, and then feeding those features to a predictive model, which might make some prediction about the rating, maybe attach some probabilities or something, and so forth. So ML pipelines are really nice in terms of providing a clean API and way to encapsulate this logic. And I'd say some of the big successes stem from, first, simple Apache Spark integration. It's right there built in, so it simplifies a lot of deployment. ETL, we might do it, say, Spark SQL beforehand, and integration into complete analytics pipelines with both SQL and, of course, in this talk, streaming. Being built on top of Apache Spark, of course, you're also able to take advantage of a lot of the core scalability and speed built into Spark. And of course, I've talked about how pipelines encapsulate a lot of elements of the workflow, featurization, modeling, and tuning. Well, so MLlib has been adopted by a lot of people. There have been thousands of commits, hundreds of contributors, tens of thousands of users on Databricks alone, and a lot of production use cases. The other element in our toolkit, of course, will be structured streaming. And I won't go into detail here. It's a fascinating topic, and you may well have heard it mentioned in the keynote this morning. There are a lot of talks on this, but I'll just mention a few things. The most important thing from the MLlib perspective is that it's a single API by dataset or data frame for both batch and streaming. Has some nice guarantees built in, as well as understanding things like external event time, et cetera. But essentially, for the sake of ML, it's this unified API, which is key. So going back to the list of challenges in productionizing ML, the way that these two elements work together really handles a lot of these challenges sort of automatically. In terms of sharing models across teams, MLlib already had a ML pipeline persistence API for saving and loading both models and full pipelines. And this really simplifies a lot of the questions around identical behavior across different systems and environments. Apache Spark, of course, does need to be deployed both in your training and in your streaming prediction environment. But once that is deployed, then by sticking with deployment within structured streaming, of course, you just sidestep a lot of the hurdles with having separate deployments. Maintaining identical behavior, for that, we really rely on the featurization logic in pipelines. And of course, there are a lot of built-in featurizers in MLlib, but you can also write your own custom ones and deploy them with streaming. And as far as having backward compatibility guarantees, as of Spark 2.3, ML pipelines do have some documented backward compatibility guarantees, and we work hard to maintain this where if you export a model in 2.2, it should continue behaving the same way in future versions. Cool, so there are still issues which you would have hit in Apache Spark 2.2 in moving to structured streaming for prediction. So I want to talk a little bit about those. The first is what I'll call two-pass transformers. This is not an official name, I just made it up. But I think it encapsulates well the kind of algorithmic pattern which you encounter, both within MLlib and often in your custom logic. So I'll give this example using vector assembler, which is a common feature transformer in MLlib for tying together a bunch of columns into a single feature vector to feed into a prediction algorithm. So the algorithmic pattern starts by scanning data to collect stats. In vector assembler, that just means looking at maybe a row or two of the data and finding the lengths of the vector columns, collecting those stats to the driver to, say, find the total number of features in the output feature vector, and then scanning the data to apply the transform using the collected statistics. For vector assembler, that means, of course, creating this new complete feature vector column of length, total number of features. So the scan collect scan pattern will fail with structured streaming just because in order to do that collection, we need to start the stream, but we're not actually ready to start the stream until we've applied the full logic of the vector assembler. So this could cause problems in certain workflows. You may not have encountered it. Vector assembler does have ways of using column metadata when available, but when it's not available, you can hit failures in 2.2 and 2.3 if you're not careful. So another common failure case was handling invalid values. And this is a little more subtle sometimes, where without proper testing, you may not actually figure this out. Invalid values, of course, can include not a number, null values, but also out-of-bound values. For example, Bucketizer can put data into discrete buckets, but you can have regions which are not covered by buckets. So out-of-bound values, or maybe incorrect vector lengths. If vector assembler expected a vector of length 10, but found one of length 11, that could cause problems too. So robust deployments, of course, must handle invalid data, either handling it smoothly and making maybe a degraded prediction, or at least failing in an expected manner. So ML pipelines have had this handle invalid param with some different options, such as skip, in other words, throw out that row with invalid data, keep it, and in some cases try to do something intelligent with that invalid value, or throw an error. But there's been incomplete coverage. So those are some of the big issues in Spark 2.2. And there have been some significant improvements moving on to 2.3. So I'd like to cover those. I would say that most transformers and models should just work. As of Spark 2.3, batch and streaming scoring and transform are basically identical, where if you have a pipeline model or whatever other model or transformer, calling transform should just work on streaming and batch data sets and data frames. There's also an extensive unit test framework put in place to sort of test identical workflows in both batch and streaming and check the results. If you're interested in the details, you can check out the linked Apache Spark JIRAs. And there are catches, however, and the issue is that those few catches are very common in workflows. So among two-pass transformers, the two big ones are, first, the vector assembler, which we were talking about, for assembling columns into a feature vector. Here, of course, you need the length of the vector columns. And as I mentioned before, you can sometimes extract those for metadata, which could be added by, say, one-hot encoding. And in this case, actually, this would not have caused a failure in Spark 2.2. But if that metadata is missing, then you need to compute the vector column lengths from the first row or two of data. And that would cause a failure with streaming. So what we did was add a vector size hint transformer, which is essentially a manual way to add that metadata, adding the vector length to a column. This is only required if you're using structured streaming, and it is a little bit of a hack. I will point to a JIRA at the end for a potential API improvement, which will avoid this manual process. The other two-pass transformer I'll mention is one-hot encoder. And this goes beyond issues with structured streaming, but also touches really all workflows using one-hot encoding. Transforming categorical columns into numerical vectors is the key point of one-hot encoding, of course. And to do this, you need to know the number of categories, in other words, the length of the output vector. And for this, again, you could either extract it from metadata, sometimes added by feature transformers upstream like String Indexer, or sometimes computed from data. In this case, of course, to know the full number of categories, you have to make a scan over the full data set. And this is actually an outright bug affecting all workloads using one-hot encoding. In particular, if training and tests do have different sets of categories, training, you have categories A, B, C, test, you have B, C, D, one-hot encoding would just mess up. So it's really important to move workflows using this to 2.3 and use the one-hot encoder estimator, which is replacing one-hot encoder. Essentially, this does the same thing, except that it is an estimator. So during training or fitting, you store the set of categories for use later on in transform in order to have identical behavior at training and test time. So in terms of handling invalid values, there have been some improvements in 2.3. Vector indexer, string indexer, one-hot encoder estimator, bucketizer, quantile discretizer, all had improvements here, as well as our formula, which is an important one, especially if you're using the SparkR API. That said, I'll say coverage is not yet complete. Most coverage does handle nana numbers. Some handles null values. But there are more improvements which have actually already been committed to master, but are not yet released and are targeted for 2.4, such as vector assembler and some further improvements to our formula in order to sort of handle invalid values for all sub-transformers it represents. So what I'd like to do is switch over to a Databricks notebook. So this is in Databricks. It's not specific to Databricks, and there will be a link later on in the slides to the code, which you should be able to run on whatever deployment. That said, this is the only parts which won't run in other Spark deployments will be either access to this particular data set and some of the visualizations. So I already have this attached to a one-worker cluster, and I'm just going to hit run all while I explain what I'm doing. Please yell in the back if you can't read the small text. So what this is doing is I'm pretending to be a data scientist working in a Python notebook and developing a machine learning workflow. The use case is credit card fraud detection. Here, of course, we're not talking about that millisecond detection at the swipe of the card, but maybe some further, more detailed processing, which could happen later on. Maybe 30 seconds or a minute or two later, you get a text saying like, hey, someone just purchased this here. Was that really you? So this is a nice case, again, for streaming, where we can do this sort of like post hoc processing to make some decisions. So, okay, what I'm doing here, of course, is not streaming yet. I'm fitting offline. So I have a data set which has these columns and I guess 280,000 rows. PCA vector is a simple set of features processed by PCA describing the transaction. The amount range is a categorical feature which represents buckets for the dollar amount of the transaction. And then the label is 0 or 1, indicating not fraud or fraud. So here's an example of the data. I'm going to ignore this time column and just focus on using the amount range and the PCA vector to compute the label. And of course, this is a really simple problem, just using the bare minimum to demo a couple of these key aspects, like one-hot encoding and a vector size hint. So here, if you look in the code, you'll see that pipeline I was mentioning. We're going to start by one-hot encoding that categorical column. We want to use vector assembler to combine the categorical column with our PCA vector. However, we need to give a hint about the size of that PCA vector in order to make this work with structured streaming. And then finally, we're going to spit these features into logistic regression and tie them all together with a pipeline. So splitting the data into training and test, here I'm going to fit on the train, and then I'm going to dump out the test to use to simulate streaming. So we fit our pipeline that already ran. And note, I'm not doing cross-validation. You could tune this better, et cetera. But I want to demonstrate using first MLlib persistence, which we were talking about as a sort of built-in to Apache Spark backwards compatible way to save and load models across Spark deployments. I'm spitting this out to a temp directory, and then I'm dumping my data as well. All right, so I'm next going to pretend to be a deployment engineer, and I am working in a notebook for this demo, but this is in a Scala API, and I'm just going to go ahead and hit run all. So in this notebook, essentially all I'm going to do is load in that model and stream in the test data and make predictions. I am setting this conf. Don't do this yourself. This is just to set the speed of the demo so that streaming can run slowly while I talk. Using ML persistence to load in that pipeline model, this handles all of that featurization logic, et cetera, under the hood. Have some logic to create that data stream. I won't go over it in detail. There are plenty of examples on using structured streaming. But essentially setting it up so that it runs nice and slowly as I make predictions. So here, all I have to do to apply the pipeline to structured streaming is, again, pass it to the transform method. After that, I'm left with a streaming data frame, which I can do, say, aggregations on. Here I'm grouping by that label, fraud or not fraud, and then aggregating in order to get the true prediction rate for each of the labels. And you can see that aggregation happening here. It's going through some records per second, and has these two distinct keys, fraud or not fraud. And we can check out the current predictions. So on not fraud, this time we did make a mistake, but the true prediction rate is still quite good. And then as far as identifying fraud, it's not bad, but with some tuning, we could certainly improve this rate. So that's it. This is deploying MLlib pipeline in structured streaming. And the main point is to show it's essentially the same except for those few catches. So I'm going to switch back to the slides. And sorry. Okay, don't have the displays set up perfectly. I just want to end with a few tips and resources. I went over things at a pretty high level here, and just want to leave you with some material you can work on or check out afterwards. So here's a summary or cheat sheet for fixing your pipeline to work with structured streaming. Essentially, the key things are update uses of one-hot encoding, vector assembler. Our formula should be okay, but worth checking. Definitely check how invalid values are handled. Beware of handle invalid equals skip, where you drop invalid rows. Of course, often in production, you don't want to throw out rows. You want to make predictions on everything, and it's okay if you have degraded predictions if you're missing data. And of course, test that. And then finally, in custom logic, whether that's custom SQL, transformers, models, beware of sort of hidden state in your logic where you need to either write custom transformers, which will outright break when you do deploy them in streaming because of two passes, or if you do have hidden state, which needs to be maintained between training and test, like with one-hot encoding. So there is remaining work I'd mention. Locality-sensitive hashing, or LSH models, do not yet work. There's a tracking JIRA, and it's because Spark SQL needs to support nested types containing UDTs, or user-defined types, which we use for vectors and matrices in MLlib. Vector Assembler Estimator is this nicer API I hinted at to sort of improve over the vector size hint hack. And then there's continued work to improve handling of invalid values, including expanded support. And I hope in Spark 3.0 we can get some changes in to change the actual default behavior to improve handling of those values. So this talk was about deployment and streaming. Of course, there are a lot of other settings, deployment and batch jobs. There are other talks in this track on that. deployment outside of Apache Spark, such as what Nick was talking about with PFA right before this, monitoring, A/B testing, serving APIs, and then above that, management for features, models, experiments. I do want to give a shout out to MLflow on hitting some of these management aspects, which Matej is talking about. There are a number of links to resources, which will be in the slides, which of course will be linked after the conference. These are for different scoring settings and kind of overview of productionization. Databricks, of course, is hiring. Please come talk to me or check out our website. And I do want to give a shout out to Bago Wei Chen, and who especially carried through a lot of this work, and to the many other contributors and committers who worked on this. If you'd like to talk with me more, I'll be available after this session or at office hours today at 3:50 at the Databricks booth. And with that, I just want to thank you. So, yeah, I'd welcome questions.
Do you have any questions for Joseph?
Joseph, can you use Spark streaming with an external model server? So let's say in your Spark streaming, you do all the data prep and then use some API to do the actual scoring. Is that recommended or discouraged?
I'm sorry, can I clarify? I'm not sure I heard the first
so
part.
The demo that you showed, right? You instantiated the model itself in a Spark streaming app or structured streaming app, right? And then you do the scoring within that.
Right.
But instead of instantiating in that same app, let's say you create a separate model server and you call that using an API. Is that discouraged or is it okay?
I see. So you're talking about running a Spark streaming job, but where that streaming job, rather than containing the logic within MLlib pipelines, it's actually calling, say, a REST API or something. I see. So I have heard of people doing setups like that, and that certainly seems like a. I think in those, depending on your constraints, certainly could be a valid setting. I do worry, I guess, depending on sort of the latency and resiliency of that REST API. Those could potentially be sort of like high variance in terms of time and robustness calls in the middle of your streaming job. But I guess my main comment would be if that is sort of the right way to deploy it for your setting, then certainly. But there are a lot of benefits if you are sticking with structured streaming to sort of maintaining logic, which was produced in MLlib within MLlib for prediction. I guess, yeah.
Okay, thank you.
We are using structured streaming in 2.2 in a Kerberos secured environment. So we were having issues while connecting with Kafka using in Kerberos secured environment. So is there any issue in 2.2 which is addressed in 2.3 while connecting in a secured environment with the Kafka in structured streaming?
I'm sorry, so let me clarify. The question is around issues hit, in particular with a Kafka connection in structured streaming in 2.2?
Yeah, Kafka connection in a secured Kafka using Kerberos and.
Okay.
Yeah.
Okay. Sorry. I think I'm not fully understanding what the particular issue is. Or are you asking if there are known issues which should be listed?
Yeah. So
I see.
Yeah. So I'm trying to ask is we have a secured cluster which is Kerberized cluster, and then when we are using structure streaming in 2.2, then it's not able to connect with the Kafka. So is there any known issue which is?
Honestly, that's getting a little outside of my expertise. I haven't worked a lot with the data sources for structured streaming, so I'm not really sure. But there definitely are experts around to talk with this. I'd recommend the Databricks booth will have office hours covering structured streaming. That'd be an awesome time where there should be some committers there.
We have time for one more question. All right, if there's no other questions, thank you, Joseph. Awesome talk.
Thanks.